Hello， 各位饭团，大家早！现在大家看得到画面吗？今天呢又来到我们一年一度的，应该说是一年一度吧，好，因为我们去年也有这个来直播。那今天呢，我们一样来直播老黄即将在 GTC Taipei 这个分享的主题演讲。那大家现在如果看得清楚画面的话，麻烦帮我回应一下。那如果声音啊，或是有任何其他你觉得现在看起来还让你不太舒服的部分呢，请留言让我们知道。好，那关于抽奖，我想应该是现在大家最关心的这件事情哈，会在我们今天的直播最后呢，来跟大家说明抽奖的办法。那请大家务必要仔细的、认真的来听我们整场好演讲。那我前面呢，因为我们现在大概10点半多一点嘛，来跟大家先做个暖身，然后待会呢也会跟大家说明一下我们今天的抽奖的一个方式。好，非常感谢，这个画面清楚，声音清楚，哇，太棒了。好，头发我好像有点乱，是不是？好，没关系，没有人在乎我的头发，只有我自己在乎。好。那因为老黄的演讲呢是11点开始啦，所以我们是提前先预热一下，好，大家就不用担心。好，那我们当然希望今天有足够多的伙伴来参加，好，那这样子好，大家抽奖起来也比较嗨一点。好，那再次声明，我们公司内部人员我们是绝对不会参加这个抽奖的，所以说这个大奖呢，4080 RTX 4080绝对是留给各位的。然后我们也会将最后抽奖的流程呢，绝对公开给大家来检视，好，所以大家也不用担心。当然不是女装，谁要穿女装？从来没有穿过女装。好，大家如果看到什么女装，那绝对都是绝对都是假的，好吧？什么来都来了。后面那个是元素周期表，对，这是元素周期表。然后还有招财猫哈，听说今天这个台股又大涨了哈，那大家心情还蛮好的这样子。大家有一些问题啊，我可以趁这个机会先来回一下这样子。好，大家为什么那么多问题？那么多问号？这个问号是针对我刚才讲的哪一句话？感谢维 We 圈圈打赏，非常感谢，非常感谢。我相信是真的，绝无作假。女装的部分是不是？好，我们过去的事情就让它过去吧。好，大家不要再执着了，好吧？卡莫99说涨到已经没感觉了，哇，这真是什么直播开始了？什么直播开始了 ？NVIDIA 那边直播开始了。好，他们音乐已经进来，他们应该要准时11点来开始啊！不要吓我们，好吧？我们今年奖品怎么缩水了？是跟去年比，是不是？各位，这个奖品的价值重点其实真的不是那块板子，好不好？真的不是这个 GPU， 好，重点是老王的签名。好，请各位不要真的抽到这个就拿去用哈。当然你要拿去用，我也管不着啊。但是你拿去用又有点。好。想知道我们这边跟 NVIDIA 的区别？你可以去看 NVIDIA 那边啊，那个原厂当然没有问题。不过我们这边就是会有即时的中文翻译，以及加上抽奖，然后还会在过程当中呢，我会跟大家打比赛，会跟大家聊天，好，来一起讨论今天我们即将从老黄这边接收到的神谕，这样子，好。台湾有发展 AI 大模型的平台公司人才吗？我觉得人才是很多，因为要不然你看这些公司，国外的公司里面其实很多台湾人啊，那但是台湾自己有没有这个资本去开发一个独立的大模型，然后能够去跟 Anthropic、去跟 OpenAI、去跟这个 XAI 来抗衡呢？大概是没有啦，但是需不需要开发一些在地的适合本地文化的一些主权 AI 模型呢？我想是需要的。好，国威的签名一点价值都没有，好，我不会在上面偷偷签名，以免损坏这个 GPU 它的价值，请大家不要担心这样。 老黄签名能卖多少钱啊？这就看你如何哄抬了，这个我就管不着了。国威讲慢还真不习惯啊。那你可以再去看一下我们的慢科学，我更慢，好不好？我们有快的有慢的啊，就是要满足不同的需求。我之前在泛科学新闻的留言，常常就有人就是说，你可以讲慢一点吗？好，所以我们才去做了一个系列叫慢科学。然后很多人看了慢科学就说，我好不习惯国威讲慢哦，或者说国威讲这样慢，我只好调成4倍速。喂，各位，对不对？那到底是要怎样？台湾有公司在收集资料可以训练模型吗？有哦，台湾其实从企业到政府，其实现在蛮积极的在收集一些语料，用来自我训练，然后也提供给国外的这些大模型公司，让他们在就是 output 繁体中文或跟台湾相关的内容的时候能够更准确。因为其实如果他们都大量用简体中文的内容去训练的话，吐出来的东西可能会大家也知道会有点走偏啦。所以说其实我们台湾的确是有单位在努力做这件事情的。差多少有120万订阅哈？感觉就是大概差个几千啦，因为现在我上面看到就是119万嘛，对不对？好，差个1000，现在是119万8672，好，所以希望今天能够突破120万这样子。为了留言才建立频道，感谢你。好，想要国威的签名没有问题啊，国威签名不值钱，所以想要非常的简单，好，看你要我签在哪里都可以，好。现在他还没开始嘛，所以我现在闲聊还 OK 嘛，对不对？好，不要变成我闲聊闲到一半，然后老黄已经开始演讲了，有在注意了，好不好？好。YouTube 只有3倍速，没有4倍速，真的吗？我买到会员也没有办法4倍速吗？我是没有调过4倍速啊，我通常都调到2倍速，了不起。刚才有人问一个有趣的问题，好，看一下。国威，你觉得全球气候变迁加剧，如今年的圣婴加剧，台湾未来各方面的能源的挑战，1到10分打几分？其实这个问题很深，但虽然跟今天没有什么关系，但可能也会有关系，因为其实老黄很多次演讲都有提到跟台湾的中央气象署的合作啦，用来预测一些我们气象相关的发展。那老实说包括今年前阵子也是缺水嘛，虽然后来运气很好，雨又下了，所以其实我们要遇到这个旱灾或是洪灾的几率现在是越来越高。那的确需要不断的提升韧性。那我其实一直很想去采访经济部的水利署，他们做这个珍珠串计划，每一个计划他们的工程到底是怎么做成的。如果说大家没有听过珍珠串计划的话，可以搜寻一下。有4倍速对吧？对啊，我记得会员是有4倍速。观看直播就可以抽奖吗？没有错，但是要到最后，而且要看得很认真，我们就会告诉你如何抽到这个东西。你不需要是会员，你也不需要是，你甚至不需要订阅泛科学，好不好？你都可以来抽奖。还是订一下是不是？好，还是订一下，但是你不需要。好，我再次强调，我们今天是完全开放的。好，老黄说能源当然了，现在其实大家听过老黄说这个5层蛋糕的说法嘛，所以最底下这一层的确可能就是电力。那其实我相信老黄今天在他的演讲当中也会提到 NVIDIA 的角度，他要如何来应对这件事情。怎么不是抽5080？哎呀，竟然还挑剔了呢？那你就别抽啊！开玩笑，开玩笑了。好，挑剔也没关系。好，跟去年一样是3题吗？这个待会再跟大家讲。好，有人跟到去年的是不是？还是说你就是去年抽到的那个人？你就是去年抽到那个人是不是？开始了吗？开始吗？我认为听到英文。还没，还没。不要担心，是广告，是广告。希望上班听直播不要被老板抓包。这个是很震惊的学习耶。这老实说，老板应该要开放所有人一起来听，好不好？这个可以算是我们台湾国运的影响台湾国运的重要演讲，一定要听一定要全公司一起来看。台湾没有像韩国 Never 这种企业平台发展大模型，但老实说啦，你说韩国 Never 去发展自己的大模型，到底能不能发展到什么程度？我觉得也是很质疑啦。对，我相信韩国人大部分也是都会用 Anthropic 啊、OpenAI 啊这些模型这样。基础设施的确是重中之重，好，所以我觉得台湾在这方面已经有很好的布局了，好，所以我觉得这个是持续可以继续观察的。卡莫99说，待会要去教课 他说我都用泛科学的影片来做国文科普阅读素养教学，非常好，非常好，感谢你。好，如果要教学生的话就离开了，就没有，因为学生没有办法允许你翘班哦。但是老板应该要去体谅一下，大家全公司一起来先来看一下这场直播，好不好？国威可以借用你3秒钟吗？你希望我做什么？请说。好，等你。好，这个 Seren0616 说去年题目很难。但很能筛出真的有在看且看懂的观众，非常好。我们今天的题目，希望也能达到同样的目的。好，我们来讲解一下我们今天的抽奖规则，也是大家最重视的部分。好，来，我们来上字卡。好，上了吗？还没看到，还要等15秒，是不是？好，好，人鱼。张月说：“看了很久的泛科学，因为工作的关系，很喜欢跟家人分享废弃物处理相关的资讯。感谢泛科学总是花大量的时间整理最新资讯，谢谢你。好，我们来说明一下哈，今天的这个 NVIDIA 黄仁勋主题演讲 Watch Party 在泛科学呢，在演讲的结束时，差不多应该是在可能12点1点哦。老实说，我不知道他会讲多久，我不知道他会讲多久。好。”演讲结束时呢，我们就会公布一个 Google 问卷，好，所以请大家要，你应该至少要有 Gmail 啦，或者说反正你有个 mail 就好了，好，然后呢，你就可以登录这个表单，那我们会在荧幕上呢秀出这个 QR code， 你可以用扫的，我们也会把连结放在旁边的聊天室，你可以用点的。然后进去之后呢，你就你最好你要登录 Google 账号哦，然后才可以填答这个表单。为什么一定要有账号？因为我们这样才可以确认这个人啊，因为我们要确认资料，最终要送出这个大奖。然后你的答案呢，必须是完全正确的，好不好？那请大家担心没有简答题，好，所以你的答案是要完全正确的，基本上就是选择题啦，好，请大家担心，也没有多选，好，就是单选题。然后呢，只要你是前4名最快答对者。我们只选4位进入抽奖资格，好不好？前4名最快答对的，你就获得抽奖资格。然后呢，这4位当然还是会有1位胜出哈。然后公布这个4位之后呢，我会现场再抽出1位得奖者，好，公平、公正、公开，好，抽出1位得奖者。然后请最后被抽到的这位，在今天6月1号下午6点前私讯我们的脸书粉丝页。然后提供这个 mail 的截图来证明你就是那个人，然后我们就会跟你联络，然后这块这个 GPU 呢就会送到你家。好，那很抱歉，因为奖品呢就仅限寄送到台湾台澎金马地区了。好，如果你现在是在海外收看，我们当然很感谢很欢迎你的参与，但是我们的奖品呢没有办法寄到那么远。那你希望请一个在台湾的朋友或家人来代收也是可以的。好，如果你在海外的话，好，那也请参加抽奖的伙伴呢。所有填写或提供的资料都要真实与正确，不要冒用或盗用任何第三人的资料。那如果有什么漏洞呢，就以我们主办单位的解释为主。好，这给我们的一个保护伞，请大家理解。好，准备要开始了，是不是？哦，不要吓我，我现在是心情很紧张。好，还有10分钟。好，有人说题目有国威几岁吗？没有。好，我先泄题，没有，好不好？我很怕人家答说这个62岁啊、52岁啊之类的，没有正确的选项这样。正常的国威好稀有。老实说，我现在也不知道正常的国威应该是定义在什么样态叫正常的国威。我觉得泛科学新闻的时候的我也是蛮正常的，慢科学时候的我也是蛮正常的。然后穿一些奇装异服的我，可能有点不太正常了。不过那就是感谢厂商干爹干妈们，好吧？有人送出一个 GOAT Greatest of All Time， 感谢你。这样的国威不够中二。我们今天重点是老黄啊，不是中二，好不好？我待会在跟大家聊天的时候，可能会讲一些会用一些中二的梗来跟大家形容一下。我们现在现场已经有1174个人正在观看我们的直播哈。那当然，我们今天的目标是要成为最大台所以请大家多这个呼朋引伴，一起来看泛科学的 Watch Party。阿燕说，第一次看知识频道直播，我们其实之前也都有直播过好几次啦。不过我们现在都是每个月固定会有会员的直播。今天变成这样，各位都有责任。是的，各位都有责任。好， 奇装异服的国威看久了也正常，好，那也好，好，那这样是逼我要更奇装异服是吗？好，这样才可以给大家一些刺激的。好，送出30颗宝石的珍珠奶茶，感谢。泛科学以后有机会讲高商合金吗？在台湾学术界很夯。我觉得有哦，这个我有在关注。好，可是我记得是前年我就有在关注这个事情，但后来没有做。今年好找机会，感谢你的建议。咪虎说没有突然讲个动漫梗，感觉怪怪的。其实我还不太知道要如何插一个动漫梗因为写脚本的时候是都想好了，慢慢加。但是如果要聊天的时候突然插这个，好像能力还不足。好，请问最后的翻译跟访谈影片会变成 YT 影片事后观看吗？应该会啊，好，都完全留存，好不好？国威会不会放水？不会放水啊，没有放水这件事情，完全就是靠运气。好，以及前阶段就是靠各位的手速，好，以及对于这场演讲的理解，好不好？以及你对 NVIDIA 的理解，好不好？好，也要跟大家说一下，因为大家知道即时口译呢，我们绝对是用 AI 翻的，所以如果有任何错误呢，请大家见谅。好，如果没有完全正确的话，那也是很自然的事情。虽然说我相信老黄的演讲，他咬字都蛮清楚，不过里面都有很多的专有名词嘛，所以如果 AI 没有办法完全的翻译出来，我可能会补充一下啦。那待会一起看直播的时候呢，我相信主轴当然是老黄演讲，但是我会在一些空档顺便插一下嘴，但不会尽量不要干扰到大家看直播，好不好？就有点像看球赛一样啊，我就是扮演Josh的角色这样子，好吧？国威怎么看华为的涛定律？其实我看到华为公布这个新闻的时候，我马上想起前阵子我们台湾清华大学有做出一个类似的研究，然后就是在讲，就是他把28奈米的制程可以加速到就是等同于7奈米的等级的晶片，那我就想，这不是很类似吗？后来老黄跟其他一些业内专家也都说这其实早就在做了，所以我觉得好像这也不是什么特别大的突破。当然有突破都是好的啦，我们就继续看吧。待会旁边会有老黄画面，因为我们今天是跟 NVIDIA 官方合作的，好，所以说我们是被授权可以使用待会演讲的画面的。好，所以待会一定会有老黄画面，大家不用担心。然后国威会说的小小的，在某一个角落。好，我知道大家没有一定要看我。好，嗨，23.5打招呼，会讲笑话吗？试试看，好不好？NVIDIA 官方台有5600人，好，看样子我们很难成为最大台了。要干掉母台有点困难，这样。早安，跟 Henry 叔道早安。AI 最大的应用会在哪个产业？老实说，我现在也很难讲，因为我觉得所有的产业现在都被影响到了。因为你既有在数位的这些 AI agent， 也有实体世界的这个 physical AI， 我觉得所有的产业都会受到影响。没错，我们是有获得官方授权哈，所以这个影片会留存，因为是官方授权的，就不会被因为有些大家知道有些台它是直接拿来用啊，没有获得官方授权，那它可能就会因为后续 YouTube 就会发一些警告啊、通知啊，就要求他把影片下架。但是我们是有官方授权。穿兔女郎装的话，我可以接受国威比老黄大，我不能接受，你接受没有用啊。台湾观众大多会看新闻台的画面哦，好，没关系，我们今天就来拼拼看，好，看我们能不能超过它，好吧？母台的字幕没有中文吧？大概没有，只有我们这边会有。好，其他我知道也有其他台有用中文啊，应该用跟我们一样的技术，就是用 AI。请问怎么获得国威阿北的签名？你就路上遇到我，然后拿东西给我签就可以了。要不然你来我们公司也可以，好吧？欢迎 John 8720711983加入我们的初级饭团。好奇怎么跟 NVIDIA 谈到授权的？ 都是因为各位啊，就是因为有各位的支持，然后大家发现说泛科学这个频道的很多观众非常的优质，所以 NVIDIA 呢就会来跟我们合作，愿意把他们的影片来授权给我们，来在直播当中用，然后也会提供抽奖的奖品。好，是不是要给各位自己一个掌声鼓励？好，就是因为各位，好，各位很棒。因为如果不是各位的话，我们自己去谈就是谈不到的，没有用啊，就是因为各位啊。好，大家都知道泛科学的观众非常的优质，好不好？对 ，NVIDIA 也有一直推广直播啦。那他们跟台湾的大概所有大学都有合作吧？那合作当然不是合作 Watch Party 而已啦，因为他们其实是在台湾各地招募人才。你看他们的新总部也正准备要开始盖了嘛，对不对？未来会增越来越多的人。对，各位很棒 ，DH3433说的没错，你很棒。好，真的没有各位的话，我们不可能做到这件事情。谁都可以串流，没有，你随便去串，它是会被警告下架的，好吧？阿贝在研究前沿科技的时候，会同时研究公司股票吗？我必须要说，我对股票没有研究那么多，好，但是我的确很热爱研究这些公司的相关的科技。对，然后谢谢 Duco937的150元打赏，非常感谢你提前祝1200万订阅，谢谢。线上突破2000人了，哇，太赞了！李弘毅老师说，李弘毅老师受访的时候提到说，现在培养人才的方向要大变革，完全同意，真的完全同意。对，又有新的音乐，好，对我们现在也不知道他几点正式开始哦，现在是剩1分钟，我相信应该会准时啊。好，现在股票不用特别研究，风口上猪都会飞，的确有点这种感觉。对，但是我觉得大家要砸身价之前，还是要好好思考了，好不好？多元的来这个分配自己的资产。何时黄仁勋开始讲？照理来说就是11点，照理来说就是此时此刻。对，现在要买什么股票及在线等？不好意思哦，我们这边没办法推荐个股，那就推荐大家多元的，去看一些其他的优质的资料来源。好，我们最近在思想实验室有上一集了，好，大家可以去看一下。哦，好像要准备开始喽。旁边的中文。大家有看到中文翻译吗？现在是在唱歌哦，然后他连歌都翻译了，连歌词都可以翻译了。这个歌应该是 Suno 或是什么 AI 做的吧？一律推荐买泛科学，很遗憾我们没有上市。大家可以打抖内啦，或加入会员这样。怎么抽奖？我们刚才有简单说一下，好像要开始了。通常前面出现这一段，就是基本上要开始了。再次感谢 Kirua 2016，谢谢你的打赏，感谢。那个旁边的中文翻译还是歌词是吧？台股上10万点，哇，这也太刺激了吧！标题打错，黄仁勋主题演讲抽 RTX 哪里 ？NVIDIA 打错，太好笑。真的打错改好了是不是？NVIDIA 真的哇，竟然有人打错，待会抓出来编。没有影片的声音吗？有没有影片的声音？好，我们来改一下影片的声音。大家听到跟我回答一下，因为我现在这一机是没有办法把影片播出来，会干扰到大家。哇哦！好，现在这个前面的影片我觉得非常重要。 有偏小声是不是？那我们可以再大声一点。这高雄画面。哇，这个是 eVTOL， 就是垂直起降的这个电动飞机。这算是人机协作，要模仿人的动作。然后现在是 AI 直接来辨识物件，机械手臂。这个是在医院里面的场景。哇，这个好像是在，比如说一些能源厂、工厂。这好像是科研型的机器人。它旁边其实都有，大家看影片，它都有提到相关的公司。影片声量有点盖过国文，没关系，因为待会的确希望大家看影片，我待会不会那么高微。再小声一点。其实我每次都很喜欢看他们开场前这段影片，我觉得都做得很好。还有这个无人的挖矿机，这真的是很厉害。因为大家知道挖矿事业、矿产事业其实工伤的意外是很多。还是 KDDI、NTD， 日本。国威的声音可以大一点，这样会不会我大，然后他又大，我大他又大？我知道也有一些专家认为说，这个 token 型的 AI 其实是有它的局限，但我们不可讳言，它现在的确还有很大的成长空间。哦，这个就是外太空算力哦。
女士们、先生们，
是哦，所以我应该要切换到 NV 的直播。
创办人暨执行长黄仁勋先生 ，Welcome to the stage。
那我要去看 NV 的直播。我看 NVIDIA 直播很怪。
大家好 ，Welcome to GTC Taiwan。
感谢大家的参与。我们的 UI 有点叠到影片了，是不是？我们来调一下。感谢你的那个建议。我要开始喽。欢迎老黄。啊，王正堂，这是什么翻译？捐生晃啦，不是王正堂。黄仁勋对 AI 哈，请大家包容。右边聊天室可以关掉吗？不太舒服。
The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan. 70 different conferences are going at the same time. Everybody is watching this keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem.
哇，你看台湾的生态系。
Computing systems that NVIDIA builds. But NVIDIA's ecosystem有
没有人的公司现在在里面呢？花娘小馆到底是哪一家？是他去吃饭那一家。他是把餐厅也纳入他的供应链了吗？府城肉粽都在里面，他的生态系也太大了吧？王记府城肉粽。好，大家如果有什么声音或画面上的问题哈，都可以提出来，我们会及时调整。哇，这个老黄供应链竟然已经把餐厅都列进去了。直播声音有点小，是不是？好，我们再大一点。
So many.
已经调了，如果还不够，请跟我们说。
The richest ecosystem, the world's best supply chain ecosystem.
这生态系太丰富了。
Thank you all for being here. And this year,
好，现在字幕应该没有挡住了哈。
Are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%.
今年预测台湾的 GDP 要成长的2位数，很惊人，根本就是2次经济奇迹的状态。对，看完才有抽奖。哇，现在已经突破3000人了吗？感谢。
The next wave of AI was agentic AI, and today we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is
这边有3张图
applications of agentic AI is software coding.
各种 AI 编码的相关数据都在陡峭的指数型增加。
30 million, 40 million
有用的 AI 已经到来。
Probably another couple of hundred who are students,
字幕请大一点。
enthusiasts, and so on and so forth. But say 30, 40 million software developers in the world.
但是我们也怕挡到图啦，所以请大家这个见谅。
Most of them. This is GitHub. The pull request.
这现在这3张图是 GitHub 上面的数据。
They modify it, and commit is when they push it back up. Okay, and so
因为现在都 agent 在跑，所以 pull request 就疯狂的增加这样。大家有用 GitHub 吗？我觉得因为有 agent 之后，大家现在可能都会用到 GitHub。
500 million commits in the first few months. In the first few months of 2026, it has nearly.
我声音太大是不是？
Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth.
写程式避不开嘛，对啊，因为以前很多人不需要写程式，现在也都开始写程式。
Is generated by $3 billion worth of salary. That $3 trillion, that $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple.
写中文的，或者说能够写字的人都可以当工程师。当然，比如说初阶的厉害的工程师是另外一件事情。
Productive work. Why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers.
老黄现在要强调哈，其实大家是需要更多的工程师。
And so the first thing is useful AI has arrived.
他其实蛮反对那种有些矽谷的公司开始裁员这种事情，他认为他们没有远见。
Tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units. Tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price.
因为这样也抽不到。虽然说看到那个旁边一直跑还蛮有趣的，但是不用刷抽，这样抽奖并不是这样抽的。我们到演讲的最后才会公布抽奖的办法。
Pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator.
刷抽其实没有用。
Is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. inside
agent 等于 LLM 加 harness。
This is an agent.
harness 是那个马
application.
驾驭嘛，对
In
不
the
对？
old days, this
驾
would
驭
be
工程，好像
application.
其实它就是骑马的时候的
This
那
would
个
be
工具
code,
这样。
and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent.
其实这的确就是我们现在在用
a
AI 的
large
一
language
个
model or
简单的
many
架构。
sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example.
现在的 agent 最主要就是它能够使用各种的工具，不管是透过 API 或透过 MCP 或者直接用 computer
Every
use。
single time it touches either processing the context, understanding what is happening, reasoning about what to do,
要
coming
抽
up
我的
with a
签名很
plan
简单，
that
对，
you
就
can act, that it
因为也没
acts
什么
on.
价值。
That orchestration path is orchestrated by some
先
software.
专心看，先专心看
So，
题
this
目
is
就在影片中。
fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do. We have long-term memory. And so the memory management
记
system
忆
is
现在是
incredibly
AI 的一个
important.
很重要的
This
突破
entire
点。
system is called an agent. The large language model is used to do the thinking, and the harness
因为我们都蛮讨厌那
connects
种
everything
AI
together.
一
Just
下
like
就
an
忘掉
operating
我们
system.
之前跟他讲什么。
Okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous the convergence of large language models that are now able to do a really
因
good
为现
job
在
thinking,
蛮恐怖的，就是有
reasoning,
多个
planning,
突破在
using
同时
tools,
发生，所以
and
我
the
们可以
fact that
发
we
现
have
这
now
个科
these
技的加速
harnesses
度在
that manages memory,
越来越快。
the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt.
哦，他举的这个例是用
This is
Anthropic
the code that is generated, and this comes out.
直接做一个
This is
JavaScript
the
的
input.
牛顿摆，然后就做出来了，
This is the input, and that's the output.
一下就做出来了。
What do you guys think? It's pretty amazing, right? We use Claude Code here, but CODEX
我
does
这
an
牛顿摆
incredible
画的
job as
怪
well.
怪的，
Here's another example.
因为我不知
This
他
is
那
the
个线到底
input.
牵在哪
Create a
里，
GIF, NVIDIA green dots on black
它
scatter.
线是在天空飞的
Form。Taiwan 101 building, morph to
直接
GTC
用这个
Taipei
叫什么？
2026, morph to
文字
NVIDIA I logo,
叫
then scatter and repeat. Right? So you saw that. That was the
哦
prompt.
做出
Here's the
NVIDIA 的
next one.
logo 这样。
I lost my remote control battery clip. It looks like this. Create a CAD file. It
哦，
uses
直
a
接做
tool.
一个
Create a CAD file.
CAD，
Ready
就
for
是做
3D
一个
printing
电
to
脑
create a
的
new
实体的
one.
设计。
Make sense?
大
This
家有
is
用
now the
AutoCAD
new
或是各
computing
种
pattern.
CAD 的工
Whereas we
具，
used to
现在其
launch
实
an
搭配 3D
application,
列印，就嘴巴
Click
讲一讲，东西就做
and
出来了
type，
这还蛮厉
we
害的。
now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been
哇，
building
感
towards
谢突破
this,
4000
and
人
now
了，
it
但
has
现在大家不
arrived.
用刷抽了。
Now, one of the big
抽
breakthroughs,
奖
of course,
的方式会在
is tool
影
use.
片结束后来
A
跟
lot
大
of
家
people
说
have
明。
said, you know, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is
老
no
黄也
longer
反对
limited
大家
by
说
the
软
number
体
of
公司要
people.
消失了。
Therefore, those agents are going to use more tools
但
than
老实说，
ever.
最终到底是如何演变，
This is
也不
actually
能
an
尽信。
incredible
好
time
我
to
们
be a
也是要
software
持续
company.
观察。
But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough. And in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now
没有要抽狗狗肉，
present these CUDA-X
跟狗狗肉
libraries
无关，好不好？
to
抽的是
agents
4080
who can use
的
it
显卡。
much more effectively than even humans. And so this is a wonderful time for COMPUTEX libraries. Let's take a look. 20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDAX libraries help developers make breakthroughs in every field of science and engineering. CUDAX libraries are tools for agents. cuLitho for computational lithography.
哇，这个很重要哦。
cuOpt for decision optimization.
光刻机曝光机而设计的。
cuDSS for direct sparse solvers. AIQ for deep research across structured and unstructured documents. Arial for AI RAN.
AI RAN 也很重要，大家知道那个
Warp for differentiable physics.
电信系统都需要这样子的
Parabricks for genomics.
的一个中枢，就是
At their foundation are algorithms.
现在把它结合在 AI 化。
Are beautiful.
哇，这个是非常高的解析度，光追啊，然后是高斯建设。哇塞，这是栩栩如生了。其实要让人的眼睛看不出来差别，这个是很难的。可以模拟实体，也可以模拟分子、原子、细菌、蛋白质，这个很重要。车子要算热气，可以做大型工厂散热 AI 资料中心，这个是来讲说这是超音速的飞机，现在超音速飞机有回馈的属性。应该是在 Cosmos 里面先进行 AI 的训练，让 AI 可以在机身使用。这个是什么机器？这是能源这个是资料中心它直接用 Digital Twin 的方式来模拟整个工厂。伟创 Pegatron 这个都是台湾的相关公司是吧？大家可以看一下下面那些小字。这个是 Mapayo 应该是他们的 AI 自驾的一个，这单量大小101，这要算城市的风吗？Earth 2 出现了，这其实他之前介绍过很多次。哇，太棒了！
A round of applause for math. Math is beautiful. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales. And each one of those steps are running in a different part of the computer. And you could see the large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with the large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated users of tools, which is the reason why the CUDA-X libraries that I showed you are going to be incredibly popular with agents. They solve some of the most important problems the world knows. And all of our CUDA-X libraries are now going to come with skills that the AI could learn how to use. So the CUDA-X library, some skills, basically a manual, the AI reads it.
会有 CUDA-X skill.
And go, aha, that's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called a DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you could see, every aspect of this computing model, this computing pattern, this new application called an agent, is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason this disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation, Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with the GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin, from end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called DOCA. The security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers. Not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle. And it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company. But over the years, we've evolved to become a systems company. You're looking here now for the most complex system, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack, just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex. Every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout,
先在虚拟的世界把所有该设计的先设计好。
simulate the power and cooling, design the network, validate every integration, test every change in the digital twin.
把可能出的包啊都先解
The
决，
factory
在
powers
数位
on.
世界先解决。
DSX OS takes over and provisions, operates,
DSX
monitors, and remediates the
是个作
infrastructure,
业系统哦。
turning the installed systems into trusted, multi-tenant,
AI 工
resilient,
厂的作业系
AI-ready
统哦。
capacity. Today's AI factories over-provision power by up to 40%. DSX Max
这个
LPS
重
lets
点哦，请
operators
大家一定
safely
要记
deploy
得。
more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts,
这有点
sending them
电
where
力
work
虚
is
量反
happening.
应的感觉。
In-rack power
来要
smoothing
平衡那个
flattens
用
peak
电的
current
频率，
spikes and power surges.
已经是电厂的角色。
Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance
要
cooling
让
and power
所有
to meet
的
workload
设备
demand.
的效能最大化。
DSX
不要有
AI
限
factories
制。
are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
竟然还说要让电网更强韧，而不是去现在大家都觉得说资料中心反而会影响电网，它反过来要让电网更强韧。
I've shown you ecosystem slides of the past where NVIDIA's computing layers and software and computing stacks are integrated into other people's platforms, third-party platforms and libraries that serves end markets. That was a computing ecosystem. This is an AI factory ecosystem. This is way downstream of all of you. Upstream of me is all of you, and downstream of us is this ecosystem. Because NVIDIA ultimately is not just building a GPU, not just building a system, we're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $20, $30 billion. It is at $50, $60 billion, and soon it will be $80, $100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, We used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true, so that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem. We call it DSX. RTX is for our GPU, DGX is for our systems, and now DSX, basically infrastructure.
DSX.
Because of the work that we do here, across this entire stack, including our systems and software, it's the reason why we could work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth $50, $60, $70 billion and growing incredibly fast. Recently, we worked with Nebius, and again, they're growing incredibly fast. Each one of these clouds have incredible customers. Cursor, the software coding company, Black Mountain Labs, Image Generation, World Labs, World Foundation Model, Revolut, the leading financial services AI company, and Shopify. Here's another one. This is Nscale, and their customers are British Telecom, Google. Google is using one of our AI clouds, Thinking Machines, a Frontier Labs company. We're super exciting. Here's Naver Cloud in Korea, Bank of Korea, Hyundai, so many incredible companies. Here's one in India, Yoda, incredible companies. Here's one based in Singapore, building in Australia, Together AI, AI Singapore. This is one in Indonesia. Each one of these companies are serving regional as well as global customers. AI is going to run everywhere. Every company will be powered by it. Every region will build it. Indosat here in Indonesia. Here in Taiwan, GMI.
这是哪一家？
Here in Taiwan, GMI. It's okay to clap.
GMI 是哪一家？
So, incredible companies, incredible opportunity, but all of them need several things. Of course, they need the computing stack. This entire stack underneath, this is what made NVIDIA famous. All of our hardware and software and libraries, our connection into the world's ecosystem of third-party developers makes it possible for anyone to stand up an AI cloud. However, the AI cloud is so complex now. This is the software version. This is the computer science version. The money version, the asset version is what I showed you earlier. It's a giant factory. Having this ability alone is not enough, which is the reason why NVIDIA has become an AI infrastructure company. Now, doing this well and becoming incredibly good at helping customers build AI factories and deploying AI factories is incredibly important. And the reason for that is this. Compute is revenue now. Compute is profit. The absence of revenues and profit is loss. And so it's really important to realize that this is an example of an AI infrastructure coming online. It could be coming online quickly. It could take a while. Its throughput could be high. It could be low. Its resilience and reliability could be good or bad. And its lifetime of usefulness could be long or short. Because this represents 50, 60, going to $100 billion. This curve matters greatly, which is the reason why NVIDIA is such a great partner. Working with us because of our fully integrated capability, we didn't just come up with a PowerPoint slide. We created the entire infrastructure. We connected everything together. We built out billions and billions of it ourselves to make sure that everything works well. As a result of that, our time to first token, our time to first token, our time to first inference, our time to training turned on is much faster. Second, because our throughput per watt, our tokens per watt is utterly world-class. And the reason for that is because we integrate everything, we design everything from the ground up, we simulate the entire system, and we use extreme co-design. Just like I showed you just now with the Vera Rubin rack, everything was designed in order to deliver on this incredible throughput. If your data center, if your factory has 1 gigawatt, it will not have more. 1 gigawatt means 1 gigawatt. That's all the power generation you could do. If you have 1 gigawatt of power, then throughput per watt is revenues, because every token is profitable. Every token is revenues. This is the future. Compute is revenues. Performance per watt is your revenues. Choosing the wrong architecture just because the chips are cheaper doesn't translate, doesn't make sense. You need to make sure that your revenues per watt, the more you buy, the more you make.
The more you buy,
and so
the
tokens
more you
per watt.
Make.
And then lastly, third is reliability. If you ever get a chance to see these data centers, there are so many moving parts, millions of cables. The ability for all of those computers to work harmoniously, reliably, is extremely low. It is just extremely difficult. We have now been operating very large scale for a very long time. That experience matters. That difference, mean time between interrupts, extremely important. And then lastly, this is very hard. The lifetime of these systems, the software is changing all the time. 4 years ago, which is in the time of Hopper, AI has completely changed. 6 years ago, this is the time frame of Ampere, AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers, and then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make. The more you make.
超级业务就是这样打。
Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard. Your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super, super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production.
全力生产中。
Vera Rubin is in full production.
上面的有哪些公司？
The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster. And we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you.
但是 Dell 后面到底有哪些台湾厂商支持？
Let's take a look.
很值得关注。
Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod-scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX-1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape through hundreds of processing steps. 3-nanometer process, CoWoS-R and CoWoS-L packaging, HBM4 memory from Micron, SK Hynix, and Samsung. The Vera Rubin compute board. 6 trillion transistors with over 18,000 components on one board. Vera Rubin NVL72 does the thinking, prompt and context understanding, reasoning, and planning. Next, a new modular compute tray, streamlined with a new PCB mid-plane design, super chips, Connect X9 Super NICs, and Bluefield 4 DPUs, all made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency manifolds, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin NVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin NVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPX takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While NVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera Bluefield 4 STX, where AI keeps its memory. Storage processing accelerated by Bluefield 4, connecting memory, storage, and in-silicon security. And NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUPE process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents. 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today, as we bring Vera Rubin to the world. Thank you, Taiwan.
谢谢大家，谢谢老黄。
Ladies and gentlemen, Vera Rubin. Vera Rubin was not just built for AI. Vera Rubin was not built just to run AI. Vera Rubin was built to run agents. This is an agentic system. Imagine the complexity, which is the reason why agents is the last computer science breakthrough. It has taken this many years for agents to realize its potential and become useful. It stands to reason that the computer that runs it is the most advanced in the world. This is Vera Rubin. Let's take a look. Can we bring out Vera Rubin, please?
来看本尊。大家应该知道 Vera Rubin 是一位很厉害的天文物理学家吧？我们之前漫科学有做一集介绍过 Vera Rubin。推出来了，推出来了。感觉像什么巨星登场一样。
And Janine, do we have the racks, the systems?
是他自己走出来的，还是被推出来的？我有点好奇。下面又东西又跑出来。
Vera Rubin, Vera Rubin NVLink 72. This is the Grok LPX. At the next GTC, I'm going to talk to you about a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology
Vera
all coming together.
CPU.
Now, when we built Hopper, we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we were working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy. We could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 72. Today, NVIDIA's token cost is the lowest in the world, not by 10%, by X factors, orders of magnitude, all because we did extreme co-design, all because we understood the computing model, the computing pattern of inference, and we were able to create NVLink 72. Now, with Vera Rubin, it is beyond inference. It is now inference in an agentic system. This is Vera Rubin. No cables, no hoses, no fans. What used to take the last time when I showed this to you, we had cables everywhere. The cables were amazing to look at. But now, there's a PCB in the middle, which connects both sides. What used to take 2 hours now takes 5 minutes. The reliability and the resilience of Vera Rubin is going to be off the charts. This is our Vera CPU tray, the most advanced CPUs that has ever been built. I'm going to show you that in just a second. And this is our storage tray. 2 Vera CPUs, 4 CX9, incredible amounts of software. This is our new LPX, LPU30, the Grok system, designed for very low latency inference. The throughput is delivered by Vera Rubin and extended with NVLink 72. If you want to extend that even further, you can have Grok LPUs. Here, we have the Vera Rubin NVLink, the switch tray. This is the switches in the middle, and this is revolutionary. Because of Vera Rubin's, because of NVLink 72 and the NVLink switches that we created and invented, and this is our Ethernet switches for scale out. What's amazing is we introduced these 2 systems for Grace Blackwell. These two systems were created for Grace Blackwell. And today, NVIDIA is the largest networking company in the world. I'm so proud of the networking team. This is such an incredible enabler for everything that we do. I'm going to now talk to you about the next major industry we're going to be part of. Thank you. Janine? Thank you.
记忆体现在是 HBM4 了。
再见。
这到底是自动还是有人在推？
I think there are 2,000 people back there
老王
pulling
跟我一样的疑问，因为很重。
Okay, let's talk about CPUs. Vera CPUs. CPUs built for the age of AI.
哦，重点来了。
All of the CPUs until now were created for people. We were the users. We were the users. We were the renters. The way we use CPUs, we live in a world counted by seconds. The way we rent CPUs in the cloud, each one of them, more CPU cores you have, the more you can rent. The economics of the use case of the old CPU and the economics of the old CPU, fundamentally different than agents. Agents are impatient. They don't live in a world that is in seconds. They live in a world that's in nanoseconds. When it uses a tool, it wants the response time to be as fast as possible. When it accesses database, it has to come back as soon as possible. Every moment that the agent is waiting keeps it from going to the next step, the next step, the next step. It is vital that we make the CPUs as low latency as possible, as interactive as possible. So we created Vera CPU for the age of AI. Now, inside our system, it's used for 3 different ways. The first way, of course, is Vera Rubin for thinking. And inside the Vera Rubin rack, there are already 2 CPUs. As you know, we are building and selling millions of Vera Rubins. We have sold millions of Grace Blackwells. NVIDIA already is one of the largest CPU makers in the world. In the Vera Rubin rack are 2 CPUs. One for orchestrating and managing the GPUs, managing the KV cache, dealing with all of the software that runs in the rack. We also have the Grace Bluefield that is used for security and isolation. The Vera compute is used for the harness, the orchestration of the AI models, tool use, accessing the database. And the data servers are right here, Vera Bluefield, the fastest storage servers, the fastest storage system the world has ever made. And the reason why this is so vital is because agents are accessing memory so incredibly fast. These systems, the storage server and the CPUs, are now the critical path of the most expensive part of the data center. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up. A CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past, we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind. The 4 takeaways. The first takeaway is that the instructions per clock of Vera has to be incredibly good because we need the latency to be short. We need the processing time, single-threaded performance, not throughput, single-threaded performance has to be world-class, absolutely the best. Single-threaded performance, which is the reason why the IPC, the instructions per clock of Vera, is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number one. Number two, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world-class. This is the first CPU that's been built a long time that is literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light, 3.6 terabytes per second.
Wow.
No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core, they're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded performance, real performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? Let's take a look.
Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU built for the agentic loop, combining NVIDIA's custom data center CPU core with the scalable coherency fabric for the right balance of performance cores and bandwidth to maximize AI factory output. At the heart of Vera is the NVIDIA Olympus core, built for modern data center workloads, branch-heavy Python runtimes, tool calls, and sandbox code execution. Each core is tuned for throughput. A neural branch predictor evaluating 2 taken branches per cycle. A 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data path. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory, while correcting multiple errors simultaneously without compromising bandwidth. Vera achieves 40% lower peak memory latency versus x86, keeping cores fed on time through retrieval, analytics, and sandbox execution. NVIDIA's second-generation scalable coherency fabric unifies all 88 Olympus cores on a monolithic mesh with separate dies for memory and I/O. Cores are not split across chiplets, enabling 50% faster core-to-core communication than traditional CPUs. And memory-coherent NVLink chip-to-chip connects GPUs directly to the fabric. Beyond GPUs, NVLink chip-to-chip can scale Vera up to multiple sockets, enabling massive bandwidth between CPUs. Vera delivers 1.8 times the agentic sandbox performance of x86 CPUs. Standalone Vera racks run agent sandboxes, tools, code, and data pipelines. Tightly coupled to Rubin GPUs, Vera keeps accelerated workflows moving. NVIDIA Vera Bluefield 4 STX powers context memory and AI storage. Compute, networking, storage. Vera is the CPU for the age of agents.
This is going to be our new major growth driver. The reviews are already coming out, and it's pretty good. That's pretty good stuff. Now remember, Grace and Vera are also the most highly qualified CPUs in the world of AI, because every single data center, every single cloud, every single enterprise, every company that works with NVIDIA on AI has already qualified Grace. The entire software stack has already been optimized for Grace. Every company will be qualifying Vera. Vera will be the most optimized agentic CPU in the world, simply because it's going to go with Vera Rubin. Simply because we made the big hard switch. In fact, during Grace Blackwell transition, the biggest risk was going from external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell. When people say Blackwell, they say Grace Blackwell, because it is utterly now everywhere. Every company's software stack has been optimized for it. Everybody's security stack has been optimized for it. And now here comes Vera. I'm super excited about that. Now look at some of the performance numbers. Speedups is one thing. It is extremely hard to speed up SQL. SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster. Not 10% faster, not 25% faster, 10 times, 3 times faster. Incredible. This is real-time. The next one is real-time stream processing. Remember, your AI is going to be not just reading documents. Your AI is going to be watching for telemetry, especially inside a factory, inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single threaded instruction execution, the bandwidth inside between the cores, the bandwidth outside. Vera is completely revolutionary. That's Vera. You know, X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPUs. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up. It's opened up a brand new market. Agents is a new workload. We built CPUs for humans in the past. We need CPUs for agents, agentic systems. The properties are different. Why would the old CPUs be the same? We are building millions and millions of errors. And to go to market with us, Taiwan's ODMs and computer makers, all the OEMs, and you could see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market. CPU for agents. And this market will surely be larger than the last. And the reason for that is because there'll be a lot more agents than there are people. And then the agents are very impatient. So, NVIDIA, Vera, CPU. Thank you. This is the most important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it. Every company will be an agent company. Every company will have agents running inside. Every company will see that agents will need its own operating system. Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the NVIDIA Agent Toolkit for Enterprise AI. You've seen me build this in plain sight. Almost everything that NVIDIA does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today. This you've seen me talking about for several years now, because we've been building for this moment. There are 4 things that companies need in order to build agents as a service or build agents to operate. The first thing you need is you need models. Of course, large language models. The smarter the better, the cheaper the better, the faster the better. The second is you need a harness to orchestrate the whole thing. The third, these models want to use tools, and these tools come with its skills. And I showed you COMPUTEX libraries. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA Toolkit for agents. It includes models that you can modify. NVIDIA's world-class open models, and I want to show you more. You can run agents from anybody. You could run Cloud Code, incredible agent, Codex, incredible agent. You could run it inside this harness called OpenShell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. its identity is protected. And so this open shell is being adopted all over the world. NVIDIA OpenShell is open source. You're gonna see so many companies adopt it. Red Hat, Canonical, Microsoft, it's gonna be adopted everywhere. This is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere, okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents
应用场景是什么？
is chip designers. It is the single most important thing that NVIDIA does.
设计
And so, of course, we have to partner with Cadence
合作
to build Super Agent, a chip design super agent. It is orchestrated by
EDA
Codex or Cloud Code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents that are optimized for the NVIDIA runtime with Nemotron. And let's take a look. It's really incredible.
Cadence 怎么用？
Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI models. Designing these chips and the systems they run in is one of the hardest engineering challenges. Trillions of transistors, three-dimensional circuits, microscopic scale, every gate, every wire, synchronized to picoseconds, must work in perfect harmony, with no margin for error. Physical prototypes are too slow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At NVIDIA, thousands of engineers, billions of compute hours per year, millions of tests, written, run, and debugged. A cycle that takes teams weeks. To compress this cycle, Cadence and NVIDIA built a design verification agent. Codex orchestrates the process. Cadence ChipStack launches the RTL verification loop, powered by Nemotron and secured by NVIDIA OpenShell. Calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The ChipStack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper. Design flaws revealed, bugs in the code fixed. What once took weeks now takes hours. Verification cycles over 40 times faster. Together, NVIDIA and Cadence are reinventing chip design with AI agents.
From weeks to hours. NVIDIA has thousands of chip designers. We are gonna hire hundreds of thousands of Cadence super agents that work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are Cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence with their proprietary knowledge. They have to start with an excellent model. We call it Nemotron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today, we're announcing the Nemotron 3 Ultra. Yep, our next open model, and it is smart. The Nemotron models not only give you the model, we give you all the data that we use to train the model. And because we have a coalition of incredible partners, you can see all of our partners down here, we work together, contribute data to each other. Nemotron is trained on one of the largest suites of long-running reasoning models, long-running tool, task-solving, tool-using data sets in the world. Because of all of our great partnerships, all of this from the model, the training script, and the data made completely available to you. This is open models at its best. The best open model system policies in the world. Simple goal is so that you can take all of it, add to it, make it even better, make it yours. Nemotron 3 Ultra is 5 times faster. Wow. This is the world's first model based on a hybrid architecture of SSM, state space models, with a mixture of experts. The architecture is incredibly fast. We made it fast so that you could think fast. When you think fast, you could think longer at the same cost. So 5 times faster. It is also 30% cheaper, 30% lower cost to run in total flops and total inference time than even the most cost-effective in the world. We're comparing against the world's best open models. Frontier Smart, 5 times faster, 30% cheaper, completely open. We're completely dedicated to this. This is now Nemotron 3. We're currently working on Nemotron 4. So this entire toolkit, from models, harnesses, tools and skills, and runtimes, is the reason why every enterprise company in the world has the ability now to create their own agents, just like Cadence did with their super agents. And we're working with so many companies, Cadence and CrowdStrike and Dassault and Palantir, SAP and ServiceNow. People were always said, Jensen, the agents are going to disrupt these markets. I said completely opposite, and you can now see it. Agents is going to create the largest opportunity ever for my partners and friends. And we have the NVIDIA Agentic Toolkit for enterprise AI to help them. So, there you go. First, Vera Rubin in full production. 2, Vera CPU, CPU built for a new generation for agents. And 3, NVIDIA's enterprise AI toolkits, so that every enterprise and every enterprise software company can build agents.
出现了，经典的，出现了。
My relationship with you started here.
Windows XP.
And many of my friends and partners here in Taiwan, your companies started here. This is, in a lot of ways, the beginning of the modern computer industry, 40 years now. NVIDIA is 33 years old. The PC industry was already starting to get to Windows 1 and Windows 2 and Apple 1 and Apple 2. And by the time that we came along, Windows 3.1 was the PC. And as you know, Windows 95 made PC personal. It took PC from enterprises, companies, and made it into a consumer electronics device. Everybody should have one, and everybody does. This is the beginning. this computing platform did several things incredibly smart. Windows was not just disaggregated, as you know. Windows was properly abstracted. It was architected just right. Systems BIOSes, open chipsets, the operating system with drivers that could be connected and installed at runtime, and an abstraction layer with a multimedia API that opened up the PC to what we all know today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now, tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya, where we're going to talk a lot more about the work that we're doing together. Microsoft and NVIDIA, over the last 3 years, it took this long to completely reinvent how the PC is going to work so that we could be ready for this moment. As I mentioned earlier, that compute pattern called the agent is going to run in AI clouds. It's going to run inside enterprises. It is also going to run on your PC. What's going to happen to that PC when it has an autonomous agent? An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. Our personal AI, sandboxed for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark. Everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek. Fused by NVIDIA. Grace CPU. 128 gigabytes of unified memory. TSMC 3 nanometer process. 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer. For creating. For gaming. For agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
哇，这掀翻了 Intel 跟 AMD 啊，掀翻了。哦，
Here it is. Of course, I got to show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him.
007游戏。
Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now,
Surface 微软自家的 Surface。
too many things in my pocket. 太多东西了。
你给他修这样了。
Okay, all right. This is the most amazing chip the world has ever built. This is the N1X that we built in partnership with MediaTek. I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that, frankly, would take 33 years to build. And the reason for that is because 100% of NVIDIA software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. You want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created and every single application that Windows has ever run.
都可以跑吗？
Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it.
真的假的？
Okay. Now, I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now, that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Super model, or it could have Claude Code or Codex or some other model in the cloud or something on the network. And it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness connected to Claude Sonnet in the cloud. I select the site, share my concept sketches and mood board of styles to inspire my design. And the prompt, a text description of the requirements and the design intent. My agent goes to work. Using the tools on my laptop, it opens Rhino and starts modeling the site, shaping terrain, setbacks, and the building envelope. Then it proposes building forms, optimized for cost, comfort, and quality. With the form defined, my agent generates the interior layout. Walls, circulation, rooms begin to take shape. I jump in whenever I want, to adjust, to change. Doors, windows, and structural elements are placed automatically. My agent detects its own mistakes and fixes them.
自动纠错。
When I approve, the agent exports the model from Rhino into Blender. Materials and object properties transfer with the design context intact. I fine-tune the materials, get the look just right. Then, I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent. Working with me on RTX Spark. Design at the speed of imagination.
What the?
PC in the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they're gonna release it for RTX Spark. It is twice as fast. It's already fast. Now it's gonna be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically everybody. Everybody will support RTX Spark and will be building incredibly smart and powerful and beautiful laptops with all of us. Thank you very much.
台湾的很多电脑厂。
But that's not all. That's not all. RTX Spark is a reinvention of laptop. But in fact, Microsoft and NVIDIA is reinventing all of PC. And today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that you see that runs on NVIDIA in all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now, what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours.
也有小盒子。
Okay. Look how beautiful it is. This agent could run 24/7, meter free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's sitting here connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this. And this becomes your personal AI, your personal AI agent. And it gets smarter and smarter and smarter over time because today we have Nemotron 3 Ultra. Tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth. And this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I am certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool, whether you launch applications, click and type. And this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, where many houses have home theaters, big TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And it's running all of your agents, it's running all of your assistants. And they're doing all kinds of things for you all the time. And you have to have it in your house, just like you have a home theater in your house, you have stereos in your house, you have game consoles in your house. You would have AI agent computers running in your house. And these in time becomes a lot more like R2-D2 to you. It becomes more like C3PO to you than it feels like a PC to you. There is no question this reinvention of the computer is as big of a deal as the reinvention of the phone into what we now know as the smartphone. And so this is the beginning of that journey. This is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I'm just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. A new line, a new beginning. Thank you.
以后都会有桌机、笔电、工作站，但没有手机。
As you know, agentic AI is just a digital robot. It understands, it reasons, it plans, and it acts and uses tools. Agentic AI is going to run across all of these computers. And you've seen me talk about each and every one of these over time. We're working on humanoid robotics computers of all kinds. We're working on self-driving car computers. We're working on satellites. You have GeForce, which has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we trained on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perception, the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning verifiable rewards, okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person, and now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we're announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There are so many people working on it. However, in physical AI, we are absolutely the world's best. I am so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3 that can understand and reason. It can generate. It can simulate in the loop. It can even be the policy itself. It is on the top of leaderboards all over the world. I am incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni-model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future, frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher, generated by compute. Cosmos, the foundation for developers of the age of physical AI.
It takes data plus compute, gives you AI. Now that we have AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open the model, we open the data, and we even open how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most, of course, the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI, agentic robot that is an autonomous vehicle, has also this complicated stack. Today, we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime with the Halos operating system, we will be able to connect to all of these services across the world. Let's take a look at this.
Hey, Mercedes, let's go to my favorite sandwich shop.
Routing to your destination. Lane is clear, pulling out to start drive. Nudge left due to the stationary lead vehicle ahead blocking our lane. Slow down to stop at the stop sign, controlling the intersection. Stop to yield to the pedestrian since the person is in our lane. Yield to the cut-in vehicle from the left. Nudge left to clear the stopped vehicle blocking on the right. Keep distance to the cut-in vehicle since it is merging into our lane. Nudge left due to the stopped van blocking the right side of our lane. They are in our lane. Pedestrian crossing ahead. Stop to keep distance to the lead vehicle. Keep distance to the vehicle directly ahead in our lane. Keep distance to the vehicle directly ahead in our lane. Stop to the stop sign since the intersection is controlled by a stop sign. Stop to yield to the cross traffic since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge left due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Nudge left due to the truck blocking the right side of our lane.
吵死啦！
Your destination is on the right.
Alpha Mayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpha Mayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GR00T is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GR00T platform, the Isaac GR00T platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human or robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today, we're announcing the NVIDIA Isaac GR00T, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot. 6 feet, 150 pounds. Just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac GR00T, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos, scaling one demonstration into thousands. Train policies. Evaluate them in Isaac Lab Arena. Deploy through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. GR00T is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac GR00T reference design robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, anywhere. The age of robotics starts here. NVIDIA Isaac GR00T.
So many robots.
Jason 说我没有被禁止卖给中国的感觉。
We're working with just about everybody who's working on robots in the world or robotic systems in the world. Let me tell you what I told you. The computer industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You'll use different models because of your preference. You will improve them for your proprietary use. You would create super agents that you can rent to other people to help them do their work. This agentic platform, this agentic pattern, NVIDIA has an enterprise AI toolkit. This is a wonderful way for all of you to engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is an entire disaggregated, distributed agent processing system. NVIDIA has really become an infrastructure company, not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs, but in the future, it'll be robots and satellites and base stations and factories in the cloud, on-prem, at the edge. This pattern, agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I am so proud of how you've been so successful this last year. The next year is going to be even more. One more thing for you. Let's take a look.
这台是谁？啊，要去夜市。这台是谁？该不会是机器人要唱歌？上次好像是唱过。Let's do this. The keynote's done at COMPUTEX. Jensen showed the world what's next. Useful AI has arrived. Agents working by your side. But in case you missed things we said today, we're gonna break it all down for you, Taipei. Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms, but they need so much compute. We hear ya. That's why we created Vera. Rubin stole the show, it's true. The cheapest tokens coming through. 10 times faster inference heaven. More special agents than 007. Bluefield keeps agents' memory true. Now, let's talk about its CPU. 50% faster, that's outrageous. Not for Vera. It's built for agents. NVLink Fusion blends ASIC smartly. Everyone's welcome to the NVLink party. Well, if you like that introduction, Vera Rubin's in full production. Nemotron Ultra leads the run. 5x faster work gets done. Nemo Claw keeps the guardrails right. Open Shell keeps the sandbox tight. Your code migrated 男人心中的中二影片。这首歌有点长。好恐怖的画面！这是什么？火影战士的画面，大家围在一起拍手。大家一起看尴尬的影片，感觉还不错。一起尴尬的感觉。在台北流行音乐中心的人，不知道现在是什么感觉。
Thank you, Taiwan.
好了，冲着最后这两个，感谢他。对，这就是黄仁勋想要的世界，没错。
Have a great COMPUTEX. 大家谢谢
Thank you.
Thanks for an
谢谢
amazing
老
year.
黄
Thank you for all your friendship and support. Thank you.
太
Take
棒了，
care.
太棒了！
Have a great
哇，老黄好厉
COMPUTEX.
害，太厉害了！哇哦，直播结束了，接下来就要来到我们重头戏喽。大家应该知道，我们今天不只看直播，我们还要做一件事情吧？那件事情是什么呢？就是抽奖，我们要来抽奖。好，那如果说我看一下现在现场有多少人啊？好，我们现在要开始来抽奖啊，已经破1万了，11000。哇，先给自己掌声鼓励。好，现在抽奖时间到了哈，抽奖时间到了。好。那我们现在呢，要来再次说明一下我们抽奖的方式哈，请大家不用再刷抽哈，因为，你刷这个跟各位刷不刷没有关系。好，我来先再说明一次抽奖的流程。好，那待会呢，我们会分2阶段的流程哈。第一阶段呢，我们会先把题目呢，透过画面上的 QR code， 还有在聊天区的连结呢，提供给各位。那请各位先准备好，你要有 Gmail 的账号。好，基本上或是任何一个 email 账号应该都可以，反正你就可以登录。好，那登录这个 Google 表单之后呢，你就可以去填答案。那你的答案基本上要完全正确。我们没有简答题，大家不用担心，都是选择题，然后都是单选题。好，然后只要你是前4个最快答对者，你就获得抽奖资格。好，说明一下是抽奖资格。然后呢，我们会在4选1。公布这个资格之后呢，我再从里面抽出1位的得奖者，然后请这位得奖者呢，一定要在今天下午6点之前私讯我们的脸书粉丝专页，好，不要传到别的地方去哦。我们有 IG、有 Thread、有 YouTube 都有，但是请只要私讯好，到我们的脸书粉丝专页去私讯我们，然后提供你的 email 截图，这样子就算完成，好，就得奖那一位了。然后再次说明一下，我们的奖品呢只能寄送到台澎金马。如果说您现在人在国外，那你可能要请您的朋友或是家人帮忙代收。那当然应该没有问题吧？应该有朋友吧？没有朋友的话，我们也可以帮你代收了哈。那你再过来拿。好，那再来就是不要冒用或盗用任何第三人的资料。那如果有任何问题的话呢，都以主办单位的规定与解释办理，好不好？好，准备来咯。等一下，好，大家都可以抽，你不需要是会员，你也不需要按赞，你也不需要是你甚至不需要是我们的订阅者，好，你都可以来抽，好不好？好，3、2、1，秀 QR code， 还有我们的连结，直接秀出来，然后请只有前4名哦，还没出来吗？秀出来，快！连结已经出来了，大家赶快点进去，在置顶的留言，然后赶快来回答问题。 连结点得进去吗？我们已经收到超过20个答案了，已经有60个答案了。哇，因为有点被挤爆，哇，已经80了。有很多错的哦，现在还都很多是错的哦，大家还有机会哦。我们现在会同时来算，因为并不是，当然是这个越早填答的越好嘛，但是你要填对啊，好不好？好，如果说现在大家上不去的话，重刷几次，因为你还是有机会的。目前只有1个人答对吗？各位，如果卡爆也不要，就是多多包涵，因为这是 Google 不给力啊，这不是我们的问题啊。就再刷一次哈，进不去再刷一次，因为这是 Google 的问卷啊，大家要相信 Google， 我们也很相信 Google。哦，已经有700多个答案了，700多个人填答了，800个人填答了，但是有多少正确呢？目前只有1个人完全答对哦。哦，还没看完，还没看完。大家多包涵，我知道这个流量顿时可能会对这个问卷网页有点紧绷，但是除了 Google 之外，我们也不知道可以用谁了。如果 Google 都用不了的话，我们也没办法。还有机会哦，还有机会哦。我们现在只有1个人，只有看到1个人完全答对，对不对？现在有多少人填答了？好，现在有人完全答对吗？有新的人完全答对吗？没有，还没有人完全答对，有那么难吗？QR code 我们先关掉咯，填完名字就被踢出去，很不好意思，因为这个真的就是我们要相信 Google。相信 Google 的伺服器有办法撑住。哦，已经又有人答对了吗？好，多1个人答对，还有2个，还有2个名额。很多人进不去，是不是？进不去真的。对，这个我们真的没有办法动手脚的，好，这个就是看运气。不会就不要写，是不是？哎，真的很多人答错，哎。对，如果太简单的话，我们也会很难审核，很难确认得奖者，所以我们的确设计了比较难的题目。这样，午餐还没吃啊。有2个人吗？有很多人都差一点哎。有人很顺连得进去哈，有人进不去。3个人答对了，还有一个。我们就是只要有4个人完全答对，我们就会从这4个里面再抽1个。现在还有1个人。 哎，怎么有人又那么有同学爱，直接把答案贴上来？这同学爱真的是人太好了。这就是在外面考试会直接，哎，有没有人想要看我的答案直接亮票那种人？有吗？又有人答对了吗？我们只要确认有4名答对，我们就结束这个第一阶段咯。哇，感谢苏米成打赏，谢谢，非常感谢。有4位了吗？好，我们确认咯。好，已经有4位答对了。好，4位答对了，感谢大家，感谢大家，已经有4位答对了。好，我们现在同步要把这4位进入第一阶段的他们的资料呢，先放在我们的简报上面。待会我们就会显示这4位，然后会由这4位再来抽出最终的得奖者。哦，好哇，真的已经算是水落石出了哈。我们的答案以及没有啦，还没有水落石出，因为其实还要再抽第2次嘛，对不对？好，我们现在来 review 一下题目好了。好，我们来请把题目放上来，我们来看一下答案。哎呀，很多人有人都答案都对，但是资料送不出去哦，可惜。但老实说，我们真的没有动手脚，这完全真的是就是用 Google 的问卷。好，我们来看第一题。大家应该知道第一题的答案是什么呢？第一题的答案是 geometry 几何力量。好，第一题答对的可以举个手哈。不是 generation， 也不是 graphical， 是 geometry。好，再来第2题，答案是多少呢？答案是 open shell。大家有看到哈？他刚才老黄在那个架构上面，下面有一个长长的青绿色的那一块，就是讲 open shell。那 Nemo Guardrail 这的确也存在，但是这不是我们题干里面问的那个东西。我们答案是 C。好，答对的也可以举个手。第一题跟第2题答对的举个手哈。好，接下来我们要看下面2题咯。好，我们来看下面2题。切换一下。终于看到题目了，不好意思，辛苦你了。下面2题，第一题，具身智能跟人形机器人，好，为了这个打造的单晶片是什么呢？答案就是 A Jason Thor。好，那 Drive Alma Pio 是给自驾车的这个模型，好，所以这个大家要选，答案是 A。在最后一题，这其实我刚才有算是提醒大家哈，这个 DSS Max LPS 在不增加电力额度的情况之下，可以多挤出好多增加40%的 GPU， 答案是 C。好，所以全部答对的，恭喜你们。好，然后成功进去问卷里面填答又答对的，恭喜你们。好，接下来我们的那个这4位的名单已经出来了吗？好，我们4位的名单已经出来了。哎，刚才有人认真听歌，对不对？所以歌里面都有这样。我听歌的时候，只有感觉到无限的尴尬。好，我们接下来要来看得奖者到底是谁。我们简报已经做好了哈，我们等一下要秀在荧幕上面了哈。老祖宗保佑我，噔噔噔噔噔噔噔噔噔噔噔噔噔，全错的也不容易啊，也是给自己一个掌声鼓励，好不好？好，全错的也很棒，有认真填答都很棒，好吧？好，要公布得奖者，5、4，不是得奖者啦， 第一阶段而已啦，不要还有第一阶段这4位看起来是谁？5、4、3、2、1，秀出来，到底是哪4位获得我们进入第2阶段的资格？题目真的很难啊，真的。哦，我们现在有这4位，分别是吴圈义、王圈琛吗？然后李圈新跟王圈君，好，竟然有2位姓王，哇，运气真好。好，那我们现在呢，我这边有4张牌，好。好，我们现在这4位哈，大家有发现它前面有黑桃红心方块梅花哈，有看到吗？来，现在呢，我手上就是有这4张 S，4张 S， 分别是黑桃、红心、方块梅花。然后待会我要请同事洗牌，我发现我自己戳就好了。好。我并没有用任何做牌的方法，我也不认识这几位了，好，我不认识这几位，好，好，然后在桌上戳一下哈，要验牌是不是？我要验牌，啊，闭着眼睛，好，我现在要在4位里面抽1位哈，我并没有用什么最新的德国高清隐形眼镜，好，真的不知道，我真的不知道是谁。好，好，我要抽咯，我要抽咯，可以吗？觉得 OK 了哈。好，眯一下，大家猜是黑桃、红心还是方块还是梅花？好，我先看一下颜色。哦，红的，不是红中，怎么会有红中？好，直接开答案。答案是都是 A 啦，什么是 A？ 红心 A。哦，是王圈新先生吗？哎，不是红心啊，对，王圈琛先生，恭喜你获得老黄亲签的 NVIDIA RTX 4080显卡，恭喜你。哎，这个名字应该不是我们公司啊，我们公司没有这个人了哈。好，恭喜你，好了，也谢谢大家的参与，好，非常感谢大家跟我们一起来看这场直播。老实说，大家也在同时看那个股市嘛，对不对？好，被点到名的也都飙起来了。好，那当然并不是鼓励大家这个无脑的炒股啦。好，那在投资之前呢，还是要谨慎，还是要小心，好不好？好，然后呢，也非常恭喜这位王圈琛。不知道是同学还是好 ，anyway， 恭喜你，好不好？那请记得到今天下午6点之前，或者说你此时此刻现在正在看我们直播，赶快将你的这个 email 呢截图，好，信箱的画面截图呢寄到我们的脸书粉丝专页的私讯，这样子我们才会后续再跟你联络，我们会再次确认身份，好，我们不会傻傻的被你骗走，好，所以其他人不要来假冒身份，好不好？恭喜大家！啊，什么叫王先生？刚才打给我要捐出来。哎呀，这个您是什么哪里来的诈骗？好，那非常感谢大家了哈，我们也是借花献佛啦，我们非常感谢 NVIDIA 这次来邀请我们合作，来让大家同步的来观看这场直播。那其实最后也再简单回顾一下，我相信老黄这次的演讲呢，他第一个重点就是把台湾150家以上的公司呢，全部纳为他 Co-Design， 这个 Co-Innovate， 好，就是共创的一个系统里面。好， 那他也再次强调呢 ，NVIDIA 绝对已经不只是一家 GPU 公司了哈，它也不只是一个 System 公司，它现在是一个 Infrastructure， 一个基础建设的公司。那要做到基础建设呢，它甚至在它的 AI Factory 的相关系统里面呢，设计出来了一个新的 OS。这个 OS 呢，里面结合了如何要让它的用电能够平稳化，然后甚至呢能够最大化它的所有 rack 的产出，而不要浪费这些 GPU 的资源。然后这次另外一个重点，真的就是把 Vera 的 CPU 推出来了。那 Vera 的 CPU 呢，当然大家也可以很清楚的知道，它就是要直接来跟Intel 跟 AMD 呢来开始对冲了哈。那到底 Vera 的 CPU 能够抢占多少的市占？那这也是值得关注的。那当然，它也在这次呢提出了最新的 Cosmos 3， 好，这样子的一个算是物理这个世界模型的系统。那这个世界模型呢，能够去解决现在实体 AI 资料太少的问题。那实体 AI 资料太少呢，会让这个模型前进的速度变慢，所以他强调 compute is data。compute is data， 所有的资料也不用 synthetic， 直接用算力来转换成资料。好，那当然这必须要有对自己的世界模型非常高的信心，才有办法做这件事情。那当然我们也可以观察说，包括这个 Gemini， 也就是 Google 阵营 DeepSeek 那边，还有李飞飞啊，还有这个杨立坤啊，这些 AI 大佬们，他们在做世界模型的人呢，他们怎么看待这件事情？然后他也强调说，他的 Nemotron 3 Ultra 也是有史以来目前为止最强的开源的大语言模型。那到底是不是真的如此？老实说，那你也要有相应的设备才有办法跑看哈。比如说他提出的可能是这个 DSS 的 Station 系列，好，或者说他这次跟微软好共同研发推出的从桌机、笔电，然后到工作站，未来到 Feynman 世代也都会有桌机、笔电、工作站，这些都可以大家来持续关注。好，那如果说大家有找到那150家公司的名单，请记得分享给我，好不好？感谢大家。好，那全错可以跟国威约会一次吗？欢迎，好，欢迎。有那么多人全错是不是？好 ，OK， 好，抽 Vera Rubin， 我们没有抽 Vera 哈 ，Vera 没办法抽，不好意思，我们等到200万人订阅的时候，我们再来抽 Vera， 好不好？200万人订阅的时候，我们再来抽 Vera。好，大家很聪明，直接问 GPT， 这也很棒 ，OK。有人要问为何合作厂商里面有小米？小米其实等于是它的，老实说等于是消费者啦。大家也看到，包括它的机器人也是跟 Unitree 语数合作嘛。那其实中国在这方面的，不管是汽车啊，又或者说家电啊、物联网啊，还有机器人啊，我们也不要回避说他们的确很强。那辉达也的确对他们来说也都还是他们的客户。应该说，小米等于是他们客户，他们都要跟辉达买这些相关的东西嘛，包括電動車的刚才讲的这些设备，所以这些晶片，所以我觉得这无可厚非啦。好的，那我们今天的直播就到这边结束了哈。如果说大家有任何其他问题的话，都欢迎再来直接跟我们联系这样子。对，那我们也非常感谢每一位。饭团也因为有你们的关系，所以我们今天才有机会借花献佛，把这个老王亲签的4080呢送给大家。那也恭喜王先生，赶快私讯我们。好，会不会他就忘记私讯我们，然后我们就再抽一次？不，谁知道会不会发生这种事情呢？好，那我们今天的这个直播就到这边结束了。如果大家有什么问题的话，就再透过私讯或透过其他方式来跟我们联络。好，那也谢谢大家一起参与那150家的名单如何找到，记得分享给我。好，我们直播就到这边结束了，拜拜。